next speaker is a futurist, an inventor, and a notorious hacker. He helped create the world's smallest PC. He created 3D printers, and now he's working for Bill Gates and Nathan Myhrvold at Intellectual Ventures Laboratories, inventing solutions to some of the world's biggest problems. I'm pleased to see a very packed house. Give it up for Pablos Holman.
Hey there. Time to have some fun, okay? So, see if you can find yourself on this chart. If we're going to talk about the future, we have to start with the entire history of the world. Not very many humans, ever. Until just 160,000 years ago, we got the first ones. Hundreds of thousands, millions. And it wasn't until just a couple hundred years ago we hit that hockey stick growth curve and got to billions, almost overnight. So what happened? Well, what happened is we solved a bunch of the hard technical problems that kept humans from thriving. How do you feed this many people? How do you eradicate the disease that's killing them? Give them jobs, give them homes. It wasn't government, it wasn't religion, it wasn't some charity or NGO. It was a new technology every time that we invented, brought into the world to solve a problem that kept humans from thriving, right? So if there's one thing all these extra humans are good for, it's making more problems. So we have to figure out how we're going to invent solutions at the scale that we create problems. So there's a buddy of mine. His name's Sammy. He's kind of a famous computer hacker. Sammy got in a little bit of trouble for writing a virus that he was using to meet girls on the internet. And he wasn't allowed to use computers for a few years. So Sammy's back now, though. I'm playing with Google Maps. You guys use Google Maps, right? You know how Google knows how to color the roads for traffic? Your phone is telling Google that you're stuck in traffic. Well, Sammy figured out he can just lie to Google. And all the roads he's about to drive on clear out, which is kind of ingenious, right? But the point is, if you think about your friends, your family, the people you know, most of them don't think the way Sammy does. If you get a new gadget and show it to your mom, you know, she might ask you, well, what does this do? And you can explain, it's a phone, Mom. It says on the box, iPhone. If you get a new gadget and give it to Sammy, the question is different. The question is, what can I make this do? And Sammy is going to flip it over, take out all the screws, break it into a lot of little pieces, and then figure out what he can build from the rubble. And it's that discovery process that's fundamental to invention. It's fundamental to innovation. And without it, you will never get any new technology. Nobody has ever invented any new technology by reading the directions. These are the guys who are violating the warranty before they got the shrink wrap off, right? And it's important to understand, we need those minds, and we need them to help us figure out how to solve the problems we have going in the future. So here's how hackers think. This is a protocol diagram. Super boring slide, but it explains what's going on with the encryption system in your web browser when it sends your credit card to Amazon, right? What happens at each stage of the protocol? What hackers will do is attack every stage in this protocol. What happens if I send a date from the future? What happens if I send 2 responses when the server's expecting 1? Or what happens if I send a 0 when it's expecting a 1? It might break. If I can get it to break, maybe I can get it to give me your credit card number or password or something, right? That's all. Hackers are going to try every deranged thing they can think of. If you're busy building a product, you need to make it work for the people who want to use it. You don't have time to think of all the screwed up stuff Sammy's going to do to it. So this is an Ophelice defensi. She's a female mosquito carrying malaria in sub-Saharan Africa. And she kills 1 million people a year. This is the most dangerous animal on Earth. Not sharks, not spiders, not snakes. The person sitting next to you is a close second. Watch out for those motherfuckers. No. Mosquitoes are killing. This is a low-hanging fruit in global health right now. And we can solve these problems, but we can't do it the old-fashioned way. We actually don't know that much about mosquitoes. We don't even know how they can fly. Their wings are like too small to be Bernoulli effect. But I have a real badass video camera, so I thought I would show you what this looks like. Okay. This is a protocol diagram for malaria, right? It spends some of its life in a human, some of its life in a mosquito. It's very complex. We don't understand that much about how it works. But what I do in the lab where I work is I hire hackers to attack every point in this protocol. We need to eradicate malaria once and for all in our lifetime. We cannot do it by reading the directions. There are none. We must invent our way out. This is the old-fashioned way of going after malaria. You spray chemicals that kill everything, and then you hope some of the good stuff comes back. This is a real ad from like the 30s or 40s. This is how we got rid of malaria in Southern Europe and in the US. You just spray chemicals. And teach your kids to sing that DDT is good for me. It's not really good for you. So we thought we should try to do better. When you're inventing, you almost always want to try and figure out if you can come up with an invention using a laser, because lasers are cool. So we thought it would be funny to shoot these mosquitoes down with laser beams. And so I hired a hacker. He bought some junk on eBay. 6 weeks later, we're tracking live mosquitoes using machine vision. And then what we do is we aim a laser at whatever's moving. And we use that to sample the wing beat frequency. And from that we can tell it's a bug, it's a mosquito, the species, and the gender. And if it's a female Anopheles stephensi, then we shoot it down with a lethal laser. Here's what that looks like. She's not coming back. Here we like vaporized her wing off. It's okay, you guys, you can laugh. You can kill as many mosquitoes as you want. Nobody's coming to save them. Yeah. It's very satisfying work if you can get it. Here we vaporized an entire bug because we had too big of a laser. Okay. This is not a comprehensive solution for malaria, but we need to add tools to the arsenal to go after these problems, right? So this is my childhood, basically, in one slide. I grew up in the cold, in the dark, in the basement in Alaska with nothing else to do. So I spent my entire childhood rebooting that thing. You're going to meet the guy who made it next. This is, I love this thing, but this is a shitty little computer. This is like the first home computer. And you couldn't do much with it. You know, the word processor didn't exist yet, and the spreadsheet didn't exist yet, but it lit up your imagination. And I was just imagining someday it'll be fast, someday it'll have more memory, and someday we'll get to use a computer to do something cool. I was fantasizing about getting my hands on a Cray XMP, which was a giant supercomputer. This is a 1 kiloflop computer. That's about as fast at math as a third grader, okay? Cray XMP, 400 megaflops, and I was just imagining what I'd be able to do with all that processing power for most of my childhood. Every one of you guys is hauling around 115 gigaflops in your pocket. And something important happened. In the last 5 or 10 years, we passed this point where humans were processor constrained. We passed the point where I wanted a faster computer. Now I got it. You've all got it. But now we're imagination constrained. We don't even know what to do with it. We have so much processing ability at our fingertips. And that's why you have, apps on your phone to make you look like a moose or something, right? Just to kill off processor cycles. Whoops. Okay. So this is what I call small data. It's a totally fake slide I just made up. It's all lies and meaningless stuff. But you guys have spent plenty of time using Excel to make charts and graphs like this in your career, right? You could just take Excel, drag it into the trash, empty the trash, and get rid of it once and for all. Nothing interesting will ever be done that way again. This is not what computers are for. This is some bullshit. It's too easy, right? If you can take a spreadsheet and fit it on a screen or fit it in your head or email it to me, it's too small. And this is not what we do with computers anymore. This is my new computer. It's a 5,000 core badass. It's on the list of the biggest computers in the world. There's absolutely no reason you should build one of these. I just have one because I think it's cool, and it has a lot of blinking lights that are blue. But you can rent these by the minute from Amazon, or almost anyone online will rent you a supercomputer by the minute. You don't need to build one. So what we do with these things is, of course, what we call big data. We do large-scale computational modeling, and it's much different than what we're getting out of a spreadsheet. This is an example. We're doing an epidemiological model, so we want to see what happens with the transmission of malaria in Africa. So we collect data, climate, rainfall, the travel of humans, all the things that can affect the spread of the disease. And that goes in this giant model. And then we run a Monte Carlo simulation that allows us to see what's going to happen to the disease over into different seasons in the future, for years into the future. So incidentally, if you go to Madagascar, you should go to the middle. That's where the people are. Malaria covers almost the entire island in the rainy season, and in the dry season, it goes away completely. Because we have this computational model, we're able to test our interventions thousands of times in software before we ever do it in the real world. What happens if I spray DDT here or deploy bed nets there? We can see what's going to happen and plot an optimized eradication campaign. This is unprecedented for humans. We're doing it for epidemiology. You guys should be doing it for every single business. Imagine a spreadsheet with 7 billion rows, one for every human on Earth, a column for every single cigarette you smoked, every burger you ate, every hospital visit you ever had. That's how we're going to do things, and it's going to give us the ability to make better decisions. But it's going to be scary, because in big data, your relationship between causation and correlation flips. In a spreadsheet, I can see if I change that cell, it affects the bottom line, I can understand how that happened. In big data, you don't get that opportunity. There's so much data you'll never understand. The computer is going to give you the best answer, but it's not going to tell you why. And that is deeply uncomfortable, which is why you should probably just, try to finish your career and retire before you have this problem and let your kids figure it out, because it's hard. Okay, so I do this work at the Intellectual Ventures Lab. We just bought one of every tool in the world, hired one of every kind of scientist, put them all on the same team, and started trying to go after the biggest problems that we could find. This is our machine shop. It's a way to cheat at invention. You can be faster if you can test your ideas quickly. One of the things we invented was a new type of nuclear reactor that's powered by nuclear waste. What a lot of people don't realize is today's reactors are only 0.7% efficient end to end. 99.3% of the energy still in nuclear waste. So with our reactor, we're able to get the rest of that energy out. Today's reactors were designed before you were born with pencils and slide rules. And they're amazing feats of engineering, but we can do better now. We can use giant supercomputers to model every neutron in the reactor core. We know what's going to happen before we build it. In our reactor, it enriches the fuel and burns the fuel right inside the reactor core, so there's never a critical mass of fissionable material that could melt down. This is a stockpile in the US, 700,000 metric tons of depleted uranium just sitting on the surface of the Earth. We computed that with this one stockpile in our reactors, we can power the entire planet, including growth, for about the next 1,000 years. That gives us 1,000 years to come up with a miraculous discovery in fusion or energy storage or one of the other things we want to be able to do. Fission works. All we need to do is try harder and engineer a new type of reactor. You guys probably heard plenty about 3D printing. A lot of people think 3D printing is interesting because of this additive manufacturing thing. I think that's pretty lame. Who cares? What I think about 3D printing, though, that's exciting is that it's a programmable factory. It's a programmable tool, and it doesn't care if it ever makes the same thing twice, right? With Makerbot, this was one of my projects. We were trying to take an industrial 3D printer that cost $250,000, make a $2,000 machine that anybody could get their hands on, and that's mostly worked. But so far, these things don't print anything anybody wants to buy, right? So it still just lights up your imagination, kind of like I described with that Apple II. With the Makerbot, we're imagining someday we're going to be able to make things with this that people want. We're going to be able to wire it up to the Buy Now button. So when you click Buy Now, robots make your stuff and drop it in the mail. And we change the way that we manufacture things. So I got kind of obsessed with this. You guys sick of hearing about these guys yet? The poster children for disruption? Yeah. How many taxi companies in the world could have made an iPhone app and didn't? They just go down kicking and screaming, right? What Uber did isn't that hard. But it's important to understand where I come from in Silicon Valley. We have a master plan. We have a master plan to take over the whole world, okay? And here's how we do it. When we invent something, when we create something that works, we fund it to scale it globally. We learned from the 80s where we fucked up. In the 80s, we invented cellular technology, and then we let every company start a cell phone company. If you go to any city, the tallest building downtown, cell phone carrier. We learned from that. There's no regional WhatsApp. There's no regional Facebook. There's no regional Amazon. No, we figured out how to scale globally. Think about all the tech companies you know from Europe. How many? One? You're naming one? How many from China? 2, 3, 4? How many can you name from California? Probably like 100 before you have to start trying. I'm not trying to make you feel bad. I'm just saying something different is going on there, and the economic value in the world is no longer in oil companies. It's in tech companies. So I'm not saying you should join us. I'm not saying we're better than you or anything like that. I'm just saying you might want to understand what's going on there, so at least so you can compete. And what's going on there is we don't try to fix businesses. We don't try to fix industries. We're going to start from scratch and use all the superpowers we have, mostly from computers, and we're going to build a new industry that's parallel and faster and better. And that's what you see going on here every time, right? Don't try to fix things. An old business, an old industry, it's successful partly because it evolved an immune system. It has an immune system, and the job of an immune system is to suppress risk. And the most obvious kind of risk is change. That's why you can't fix them. And that's why we don't try. We just start from scratch. and make an end run around whatever business, whatever industry thinks they're on top. Okay. So if you're trying to disrupt, what you want to look for is the most fucked up industry you can find, right? Okay. So here's one that I got interested in. In America, we used to make clothes. This is a yarn spinning operation, so making the thread that's used to knit or weave fabric, right? That's how we did it in America. We don't do that anymore. This is where we do it now in Asia with a particulate filter, so a lot of high tech involved. We used to sew. We don't do that anymore. 100 years later, we do it in Bangladesh with a particulate filter. So lots of advanced technology going in. So we're doing the same thing for the last 100 years. Whenever you can find that, there's a chance for you to reinvent an industry. This is what happens to factories in Bangladesh. Meanwhile, it's a very inefficient industry. We grow the cotton in one country, ship it to another country to be beaten down and bleached out, shipped somewhere else to be spun into yarn, shipped back to be knit or woven into fabric, shipped somewhere else to be cut and sewn into T-shirts, and then shipped back to Europe or America, where we screen print team building exercise 1999 on the shirt. You wear it like 2 or 3 times and throw it in the bottom of your closet. That's $4. Lot of inefficiency there. So if we could reimagine that industry now, would we do it the same way? That's the opportunity you're looking for in disruption. I got interested in this. There's other problems. You know, I mean, I don't know about you guys, but in South Africa, they have a wildly skewed perspective on American football because apparel manufacturers have to guess what's going to sell. They just print T-shirts for the winning team and the losing team, sell half of them. The other half, they make a charitable donation to South Africans. They don't know about American football. It's fine. So you have so much guesswork in that business. Fashion designers don't have it any better. They have to send something down the runway, take orders, fax them to China, wait 6, 7, 8, 9 months for it to come back. You put it on the shelf, hope it sells because you hope you guessed right. You hope you guessed about the designs, the colors, the sizes, the volumes, all those things. Usually it's hard to get all that right. So think about how we made software. This is how we made software in the 80s. You dream something up, you roll out of bed, write code for like a year or two. That goes on the floppy disk in the box, shrink wrapped on the shelf at the App Store, where you can drive there and buy some software. Inside that box is a postcard. And you can write bugs on it and mail them, lick a stamp and mail them into Microsoft or Adobe or Apple. That's what we were doing. Compare that to how we make software today. I dream something up. I roll out of bed. I write code. Launch it at lunchtime. That's your web apps. That's your mobile apps. All afternoon, people are emailing me pissed off that something's broken. I'm fixing bugs. I launch another version and go to dinner. 4, 5, 6, 7 versions a day of your web apps and your mobile apps. So this is the key thing that matters. When we say software is eating the world, this is what we mean. We went from a world where we had to guess 18 months in advance what the market wanted to the world we live in now where we just A/B test our way to success. You can hire dumb shits to write iPhone apps. They don't actually have to be so smart. We pretend we're really smart. You don't have to be that smart because you don't have to guess a year in advance what's going to sell. You can just test and steer until you get there, right? You'll find your way. And that's much different. It's so powerful. That's why software is eating the world. And because of that, we're trying to make everything else in the world. Hey, can I have that thing? Wait, where are you going? No. We're trying to make everything else that way. This is why Arduino and Raspberry Pi matter, because they give you the ability to turn all that electronics messiness into software Lego bricks that you can build with. Right? You used to need a chip guy and a firmware guy and a sensor guy and all kinds of different specialized knowledge to make an electronics gadget. Now, you just need a Raspberry Pi and a USB cable. That's why you have Fitbit. That's why you have GoPro. That's why you have all these different gadgets, because it's easy. It's software now. But once you're back to making physical stuff, then you're back to year-long development cycles. You're back to tooling. You're back to economies of scale, Henry Ford-style assembly lines, and it's slow and expensive. And that's why 3D printing matters, because it shows us a future where we might be able to change that and make physical stuff the way we make software. So I started trying to play with this. I don't have anything to do with this, but I got excited. Sometimes I get excited when I see cool new things. This is CAD software for clothes. You just draw something, set it all up. We haven't made anything yet. We're just drawing something on a computer, and watch this. We see what it's going to look like before we've ever made anything. So I started thinking, what if we could reimagine the way we make apparel? Every human on Earth is a customer. This is a big industry. We can make self-driving cars. We make surgical robots. How long do you think it'll be before we can ever make a self-driving sewing machine? What's missing in this video? There used to be a person there, right? Humans. This is a prototype, so these don't really exist yet. But when you think about all those factory dungeon jobs in Asia, most of them are sewing. And we don't need a miracle to make this thing. We're probably just a few years from using engineering abilities to make this work. You've seen a lot of cool robots on the floor here today. None of them probably are sewing yet. But once it does, there's a sea change in that industry, right? I got excited and tried to make a company that worked this way. So what Bombsheller does is, we just let artists make designs, and then they stick them on their computer, and then the next thing you know, it's a product. And we do that differently. So if you look at the winners in the apparel industry right now, it's Zara, H&M, the companies that got their product cycle down from 9 months to 9 weeks. We get it down from 9 weeks to 9 hours. So here's how it works. It's so easy, I just have to show you. Like, there's a template in Adobe Illustrator. I'm not much of an artist, so I downloaded this map of Seattle. You drag it onto the template, and you're done. Like, that's how you make a design. So you guys can all go home and do this tonight if you want. And then we use 3D video game Babe to model it and show customers what it's going to look like before we've ever made anything. And then, we have a big market. Dancers wear leggings, people working out, rock climbers, runners. I don't know what that is, superheroes of some description. Anyway, the point is, if we place an order right now, they get printed tonight, cut and sewn, and shipped tomorrow. And it's mostly automated. So there's no inventory. If you talk to anyone in the apparel industry, they have battle scars from inventory management and getting it wrong and having to liquidate thousands of something that didn't sell and all this kind of crap. We don't have those problems. We don't make anything until we know who we're making it for. And we don't have any middlemen. We have no retailers because it's online. No reps, no distributors. All these people used to take a slice. We got rid of all of them overnight. And that's a way to reimagine just one industry. So see if you can find yourself on this chart. I made this for Americans, so you guys are all exempt. But you can just pretend. If you're in the bottom 99% in America, or the bottom 1%, you're still in the top 14% globally. That's pretty good, right? It's like being a lottery winner. You got to be mammals, and then you got to be humans, which is pretty good for being a mammal. Nothing coming after you but mosquitoes, and the reproductive process is enjoyable. So, what I think is, at some point, we need to recognize the world has overinvested in us. A lot of money, a lot of education, a lot of energy was all spent on me. And I need to do what I'm uniquely good for. right? The world doesn't need me farming and mining coal. We need to do what we can do. If you have an iPhone in your pocket, the cost of that thing is equivalent to the global median income. I'm not trying to make you feel bad. I got piles of these things. Buy an iPhone, buy a Tesla. That's cool. That's what you should be doing, because we need to make an early market, advance these technologies, and figure out what works, but then go try to solve a bigger problem. In Silicon Valley, we have this religion we call scratch an itch. Scratch an itch means find some problem you have and solve that, because it's like budget market research. If you have this problem, your friends probably do too, and there you have a market. Well, what I think about that is it's good practice, right? Learn to ship a product, learn to support it, learn to get customers, all those things. But then go take a problem on that 1 billion people have. Take on a problem that you don't have. My problems, look, we're running out of problems, guys. My problems are like, you know, my iPhone battery doesn't last all day, and relationship problems, okay? We don't have existential problems, but there are lots of people who do, and the point of these technologies is to solve them first. Here's an example. This woman has taken $25,000 worth of vaccines, packing them into a $2 styrofoam cooler. She's going to truck them out into rural Ethiopia, start injecting kids, and about half of them are going to fail. And they're going to fail because they didn't stay cold. That's all. We have no detection for that, so we inject kids anyway. 250,000 kids a year die of something they were vaccinated against. Now, I don't have this problem. I got refrigerators. You don't have this problem. It's normal for the power to be out for 4 to 16 hours a day in these countries where we're trying to run these vaccination campaigns, right? So we invented this thing. It's a kind of super thermos. It's not a big deal. You put vaccines in there, stick it in the sunshine, in the Sahara, come back a couple months later, and your vaccines will still be cold. There's no external power. You can't plug it in. It just stays cold. And this is a way to dramatically improve those vaccination campaigns. This is literally the deployment scenario. Yeah. You strap this R2-D2 looking thing to a camel, truck it across the Sahara to a tree where you set up a clinic and inject kids. We can do better, but we have to try. We have to go where these problems exist, understand them, and try to solve them. So thank you.
Thank you very much, Pablos Holman, for your visionary
Thank you.
talk. We appreciate your comments.